Hello, everyone. So we're now on the last lecture within the series on speech, and we're going to talk about text-to-speech, my favorite part of speech, because that's the bit I've been working on most of the last some number of years. Often called TTS, text-to-speech, sometimes called speech synthesis. This is generating understandable, natural speech waveforms from some textual representation in a particular language. There's usually talked about three different levels of analysis that you have to care about when you're doing text-to-speech. The first thing is you've got a string of characters. We'd like to be able to get the words out of it. This involves tokenization. So if we're Thai, Japanese, Chinese, we have to be able to do word segmentation. We would also have to deal with what we call non-standard words. This is things like numbers and symbols, etc. We have to have some decision about what we're going to do in pronunciation. Once we know what the words are, we have to care about the pronunciation. That might be trivial, or it might be complex, like English. That might be done by some form of lexical lookup or some model that gives us the pronunciation into a phonetic form. And we have to care about prosody generation, particularly phrasing, intonation, duration, etc. Then once we have all of that, we've actually got to make the waveforms. We've got to actually make it say something, and we'll talk about the techniques and technologies that we use for trying to do that. Okay, let's talk about the text analysis first. This may be trivial depending on the type of text that you have, and it might be arbitrarily hard depending on the type of text you have. So I've just got some examples here. This is a pen. That's pretty easy, nice separated words. That's very easy. Each of the words, you look up the pronunciation and things are just fine. Let's look at the next one. My cat who lives dangerously has 9 lives. Notice the word L-I-V-E-S is written exactly the same, but it has a different pronunciation, okay? The first one is a verb and the second one is a noun. And because of that, they have a different pronunciation, lives versus lives. You got to get that right. So at least in English text-to-speech, you sort of need a part-of-speech tagger, otherwise you're going to get things wrong. There are a bunch of other words that are like that, project and project, that you're going to get wrong. Let's look at the next one. He stole, okay, so we're not going to get this in the lexicon, but somehow we have to get the pronunciation of $100 that's reasonable. So he stole $100 from the bank. So they have to have by rule, and you can do quite well by rule because the pronunciation of numbers is often quite well defined in languages. And we have to make sure that we get the plural in the right place. We have to make sure that the dollar goes after the number and not before in the pronunciation. So you say $100. You don't say dollars 100. So we have to care about things like that. Let's look at the next one. He stole 1,996 cattle on 25th November 1996. Notice the pronunciation of 1996 in English depends on what you're referring to. If you're referring to a quantity, you'd say 1,900, possibly have an and or not, depending on where you grew up. 1,996. Well, if it's a year, you say 1996. If it's a street address, at least in America, you'd say 1996. If it's a telephone number, you probably say 1996. If you're in the UK, you probably say 1996. So there's some different pronunciation depending on how that number is actually used. And the 25 is pronounced as an ordinal because it's 25th of November. And where did the off come from? Well, it comes from somewhere. And so you have to care about these things. If you don't do these things, people complain and they don't understand it. And they say, that's not right. How come you can't read properly? For the text-to-speech engine. So let's look at the next one. Oh, it's okay. So we've already got rules for dealing with $100. So he stole $100 million. Wait, $100 million? No, it should be $100 million. Now, the word dollar goes after the word million. Okay, and so we have to deal with that too, because that's something that happens in English. And so we have to deal with it. And we've got to deal with billion, trillion, quadrillion, arbitrary other million word in there to be able to get it right. Let's look at the next one. It's 13 St. Andrew's Street near the bank. And so we've got a saint and we've got a street, and these abbreviations are incredibly common. and we have to somehow be able to work out which one's which. We expect the synthesizer to do it and not think it actually is street or I'm going to skip the next two, but you can see that you're going to have to choose about pronunciation of more complex forms, again, depending on the type of text that you're actually dealing with. We call the things that are not standard words, they're not just simple lookups in the lexicon or a simple use of letter or sound rules, non-standard words, NSWs. These are things like numbers. They may have different pronunciations depending on the context, or they just may have pronunciations that you actually have to care about, and they're sort of not in the words, and you can't have a lexical lookup for all of the integers because there's quite a lot of integers. Dates and times are also issues as well, that you have to choose how to be able to do it. They often have standardized forms in particular languages, and sometimes they get borrowed from other languages, and you have to work out how to be able to say them. And sometimes, rather confusingly, there are some countries that do it the opposite of everybody else on the planet. I'm talking about you, America, where they flip the month and the day around, and you've got to choose some way to be able to say them. I still get confused with that. We also have other things which are not pronounced as words or may not be pronounced as words, and these are things like abbreviations. And we don't usually say the abbreviation as an abbreviation. We usually expand it. So we don't usually say etc, we would say etc. And so we have to know what the expansion of abbreviations actually are. And for standard ones, it's pretty easy because it's, again, the lexical lookup thing. But you get new ones that you've never seen before. And so in particular domains, say like if we're talking about CMU campus, we often put in abbreviations for the buildings, and the buildings have got letter sequences, so WH, and we have to know what that means. We can say WH 4525, but we probably would say Ween Hall, and we'd like a synthesizer to say Ween Hall 4525. And so somehow we have to learn that, and that's not going to be in a lexicon unless we know something about the particular area that we're dealing with. We also have to know, given something we don't know, is it abbreviation? Is it a letter sequence like CIA, or is it pronounced as words? I put the word CASA in there, which looks like some acronym, but I made that acronym up. But I think most people would pronounce that CASA and know it's CASA rather than CASA, but well, that might be okay. But then you get combinations like CD-ROM, where the ROM part is produced as a word while the CD is not. And remember, you know, if it was DRAM, would be that be DRAM or DRAM? So you have to choose something about that. You have to do something sensible, otherwise people are very confused. And there's, to confound this a little bit more, there could be language IDs. So depending on the language that the word comes from, there may be different pronunciations or different ways you're going to choose between the pronunciations. So we have to care about that. Okay, non-standard words are sort of hard because there's an awful lot of them, but they're relatively rare. And depending on the genre of data that you have, you may have to deal with them quite a lot. And people will not understand the synthesizer if you get them wrong. People don't understand, unless they're non-natives who recently learned it, how hard it is to pronounce some of the things that you actually find in text. Let's go on to pronunciations. We probably need a lexicon. We can probably get away with not using a lexicon and using graphemes if the language is like that and if there's no borrowed English words there. And if we train just on graphemes and we build a system that just cares about graphemes with no pronunciation, remember, sometimes it will be wrong. And then there becomes a question about how do you correct it, you know? So you build your synthesizer, it's excellent, you didn't do a pronunciation, and it gets your boss's name wrong. How do you fix that? Okay, because you can't say, oh, well, add another lexicon. No, you don't have a lexicon, so you can't add a lexicon for that particular name. And so you have to do something. So you probably have to map that word into another word that would get the right pronunciation. And people don't really care about that enough, but it's really important to get some names right. And even though many languages have well-defined pronunciation rules, there are always exceptions. And if they're common things, actually a full end-to-end grapheme-based system will usually get that right. But the less common ones, it won't get right. And you should have some way of fixing that. Otherwise, people get very annoyed when their name is wrong. And English words are all over the place, which just makes your life really easy, even when you have a nice pronounceable language. What about prosody? Um, by prosody, I'm actually meaning three things. Phrasing, how do you get chunks, sometimes called breath groups, although you don't necessarily have to have a breath. Um, Actually, in most languages, if you know about function and content words, okay, this gives you lots of information about where a break could be. In English, we are likely to have breaks between a content word and a function word. So we have the girl in the park. We're much more likely to have a break between the girl, and in, the girl in the park, rather than between in and the, or the and park. Okay, so the girl in the park is weird, okay, while the girl in the park is fine. And so if we know about function and content words, we can actually get somewhere. Now, it's not necessarily going to be like that in other languages, but knowing about function and content words, for example, in Japanese, an acceptable place to put break is usually after a function word and before a content word, because most of the particles in Japanese are post particles. So if you have watashi wa, there's likely to be a break, or there can be a break after that. And so if we know about function and content word, okay, that's a light form of part of speech tagging, we can actually make predictions about where the breaks would be, even in languages we don't really know. Especially if we have some training data. And we probably have some training data because we need to have recorded data in order to be able to build a synthesizer. There are unsupervised ways of finding function and content words that work fairly reliably. We've got tools that will do it naively and just look at the distribution of words and frequency and look at their context, and it will sort them into groups. These may not be identifiable. No, it does not identify that these are conjunctions, determiners, or whatever. It just says these are really common and therefore they're probably function words. And I don't know anything about the other ones, so they're probably content words. But that helps. And if you have that information and you get that tag group for whatever it is and try to train a model, you can typically get something that's quite well. There are two components in trying to care about phrases. One is this particular boundary between two words likely to have a break in it, or how likely is it compared to the other breaks round about it? And the other component is actually looking at a long-term issue of how many breaks you've had so far. So you can actually use your standard noisy channel model, split that with the Bayes rule, and end up with a language model for the amount of breaks over time, and also the probability of a break or not break at this point, what the part of speech context, function content context actually is. I'm going to say something about that later, but let's go into intonation. The underlying tune may have explicit accents on words. This is some bump, something that happens intonationally. It varies from language to language and even dialect to dialect. The phrasal tune, so looking at that phrase that we get out of the phrasing, may also affect people's interpretation, and it can be very language dependent about how it is. And if you get it wrong, people think it's a foreigner speaking, and it can make it harder for people to understand. Duration, we have to care about the durations of the actual phonemes. This is actually quite hard to get completely natural. And for most synthesizers, if we replace the synthesized duration of all of the phonemes with a natural duration, everybody thinks it sounds better, which means we're not really succeeding with the durations. Even though we've got elaborate ways of training that, there's still some component that we're not getting right yet. Speed of delivery is quite interesting. If you want to be able to tune how fast the synthesizer speaks, it's not just the speed of the phonemes, it's also the number of breaks. So when you speak slowly, you make more breaks between the words, the phrases. But when you're speaking fast, you stop putting any breaks in and you just speak continuously. And so you want the knob to play with the number of breaks as well as the actual speed of the phonemes. And this is quite important if you want to sound natural. And so this would affect effectively the probability of the breaks. You want to tune this and make the distance between the breaks longer if you're trying to speak faster or less. And it's not monotonically increasing. You don't put a break here and then you put break somewhere else. These breaks will change their position depending on whether you have one or two or three, and they may not be in the same place when you're wanting more breaks. Expressiveness, okay? So we don't just want a boring red newsreader. Well, that's usually what we get. And it's not just the choice of words when you're generating style, although that's got a lot to do with it. It's also how they are spoken. Most speech synthesizers end up with a professional voice. They do that somewhat deliberately to put a separation between the character, the agent that they are, and the person that they're speaking. It also encourages people when they speak back, they typically will use the same style back. And if you speak more professionally to it, it's going to be easier to do speech recognition. That's somewhat deliberate in things like Siri and Alexa. But that might not always be the appropriate form of speaking, and you might want to be able to vary it. It's very likely you'd like to have control of expressiveness and being polite and being informal. You don't really want to have an impolite synthesizer. You want commanding, please leave the building immediately. You would like that to be quite forceful and clear that it's a command and it's not a request. You'd also like certainty. It'd be quite useful when a dialogue system is replying to you. If it's not sure about something, it should sound not sure. And when it is sure about something, it should sound sure. Often when people do expressiveness, they think about emotion. And so many people in text-to-speech experiments do things like in trying to do a sad, a happy, and an angry voice. I've never had to use a synthesizer that needs a sad voice, a happy voice, and particularly an angry voice. When we were doing our spoken dialogue system for bus information for the Pittsburgh public, one of our research projects was looking at how to calm down the speaker who was angry or frustrated. And I suggested that we should make the synthesizer angry back at them. And I was voted out. I wasn't allowed to do that, even though it would have been way cool to have an angry voice. And you said, where's the bus? And the synthesizer says, I told you it'll be there 10 minutes ago, but we're not allowed to do that, even though that would be fun. Dialect or register becomes really important when you're dealing with speech synthesis. You want the voice to be appropriate for the task. If you do not have a voice in the language, you probably want to go to the most common dialect of the language, the one that's most understood and the one that people are most familiar with. Think BBC English for English. You know, people may not like that received pronunciation form of English, but they're probably familiar with it because they've probably listened to some English. That's if you were doing English, but there's equivalent in each of the languages. Be aware it might not be the favorite, but it might be appropriate. Now, but you might have to be careful about this because if the Scottish National Party ended up with a synthesizer that was BBC English, they would be laughed at because it's not appropriate, okay? So in other words, they would probably not do that. They would look for a Scottish one, or they look for some other dialect of English that was just equally inappropriate, like an American accent. They could use that in Scotland and people would just, everybody would complain about it, but they wouldn't think it was wrong, okay? While if you used a Southern English voice in a Scottish particular form, and this political aspect of choosing the right voice is actually really important, and people will hate you for it or not. So it's something that you have to think about when you're actually choosing it. And be aware that the people you're asking may be privileged in a way that they're not obvious, it's not obvious to them, and therefore you should be a little bit sensitive about trying to find out what the best appropriate accent is. Usually radio shows are just fine, but think about that when you're actually doing it. Okay, so we're now going to the next stage, which is waveform generation. I'm going to play some examples here of different forms of doing synthesizers actually over the years. Hopefully these will all work.
Ferment synthesis is an older technology, most famously in tech talk, that produces understandable synthesis, but is not so natural. It is, however, quite suitable for discussing the beginning of time and black holes.
That's Professor Stephen Hawking's voice. When I say that's Professor Stephen Hawking's voice, I mean, it actually is his voice, or at least he had, before he passed away a few years ago, he had two physical pieces of equipment that spoke. And that came out of one of them way back in the early 2000s. He sent it to me to build a software version of that physical hardware. That is actually Clat Talk or Deck Talk. It's actually from a company called Speech Plus. And although that's not very natural, it's pretty understandable, okay? But it sounds like a synthesizer from the 1980s, because it is, or it sounds like Professor Stephen Hawking. The problem is that that speech is created from subcomponents and put together sort of by rule. There's some training in it, but it's mostly by rule. And therefore it's hard to get the naturalness out of it. And what would be better if we could record natural speech and take the pieces of speech and join them together. And that's what this next one is.
Lawrence Olivier for Diet Coke. Hello, I'm Lawrence Olivier. I've been dead for over 2 years now, but through the marvelous technology of tape editing, I'm able to speak to you from beyond the grave. What you are listening to right now was made by cutting together things I said in my many films and interviews.
This was done by taking random recordings from his films and interviews and put together. You can hear that these things are taken from different acoustic backgrounds, and therefore it's sort of distracting when you're actually listening to it. And therefore we don't really want to do that. It would be better if we could actually record in the same environment, and so that we don't have these acoustic mismatches. I don't think we got to the stage where it was actually playing words that had never been said before, and they have to piece together from subwords, and the quality in that example gets really bad. So maybe what we want to do is we want to record the same person in the same acoustic environment, get all of the phonemes, and then try to piece them together, and we get something like this. It's best described as sucking, and it actually says this is a short example. It has no control of the duration and prosody, so it says all of the phonemes are an equal length. This is a shorter example. Now that I've said that, if you listen to it again, you'll probably understand it. But that's not good enough, because there's not enough examples of phonemes, and you really would like to be able to choose the phonemes from the appropriate context. Also, we are splitting these units at the phoneme boundaries, which are the most interesting part of the speech, where we're transitioning from one phoneme to the next. So instead of doing that, what we could do is we record all phone-phone transitions. So we actually are selecting transitions between phones rather than individual phones. So that would approximately square the number of units. These are called diphones. And we used to do this well into the 2000s. And this is what most synthesizers did up in the year, I don't know, 2005, 2010.
This is a short introduction to the festival speech synthesis system.
It sounds pretty good. It's very understandable. It's much more natural. It's maybe not got the variation of natural speech, but it works quite well. It's very careful recording, and we have to do things quite carefully when we're making sure that the people say the right thing. But people realized that this was a little limited, and maybe we should have natural speech and then select appropriate units from the natural speech. This is unit selection, which was fashionable back from mid-90s up until 2010 and maybe later than that. There are still commercial synthesizers out using this technology. Oops, lost the...
This is a short introduction to the festival speech synthesis system.
You get something that's much more natural. I'm going to skip the next one, which was a fully automatic. I'll just play it. It's a fully automatic build from an hour of speech.
This is a short introduction to the festival speech synthesis system.
Quite natural, but the breathing's weird on that. Okay, and that's something we'd like to do. And that's only done from an hour, actually 45 minutes of speech. And most unit selection voices are really done from 10 to 20 hours of speech. There was another technology in the 2000s that was very similar, corpus-based. It's based on the recordings that we're actually doing. But instead of selecting particular units, what it did was it tried to take an average of similar units and then did a generative model. This had huge advantages, that the databases were much smaller. You needed less data. It didn't have to be as well labeled, but you lose a little bit in the quality. Okay, it doesn't have the same brightness as what the unit selection was, but it's still pretty good.
This is an example of ClusterGen, a statistical parametric synthesizer trained from the same 1,100 arctic utterances.
And because, you know, it could build models that were a few megabytes in size rather than a few gigabytes in size, this was fashionable when you were doing things on the phone, and also you've got crappy speakers on your phone, so that's sort of okay. In 2016, the whole world of speech synthesis was changed by DeepMind, who said we can predict actually the whole waveform directly using neural forms, and we ended up with WaveNet that sounds like this.
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser.
Now, actually, the best WaveNet synthesis is equivalent to the best unit selection synthesizers, because it sounds like pre-recorded speech. But it more often sounds like pre-recorded speech than the unit selection ones. The unit selection ones will make errors, and even though there's techniques for tuning them and there's techniques of making them be in a particular domain to make them better, WaveNet is much better. It's computationally very expensive. Even now, 4 years later, although we can do it in real time, we don't get it to be real time on a phone, okay, which maybe we'd like to be able to do. All of these later things are corpus-based. We're basically recording people's speech, because we find that's the best way to actually model it with examples rather than trying to reconstruct it or decompose it into different forms. And unit selection, statistical parametric synthesis, and WaveNet all depend on that. And then the question is, when you move to a new language, what do you record? Now, sometimes you get given that and you can't do it because you get an audiobook or a Bible or whatever. But if you do get some control, what would you record? So we've got a bunch of tools that actually allow us to do that get the right type of data, domain, style, phonetic, prosodic coverage. We and others, although CMU's been at this for a lot longer than others, and many people copy this and build on top of it, including commercial companies. The FastFox voice building tools is a suite of tools that allow you to be able to build voices in new languages as well as voices in existing supported languages. It's got things like make nice prompts in it that you can actually give it a Wikipedia, and it will give you a bunch of utterances that you should probably record from it. It often helps to go through it by hand and remove the stupid ones because it doesn't really know what it's looking at, especially in other languages. But it only selects high frequency words, which means there's probably a standard pronunciation for them, okay? And the reader will know the pronunciation. We get sentences between 5 and 15 words because we want people to be fluent. If you get them isolated words, they say them in a different way than if you give them full sentences. And we don't want these sentences to be too long that they make errors when they're actually reading them, or they're hard and have to re-record them. We've got alignment tools, so you can take whatever you got and try to find out what the best alignment actually is. We've got universal pronunciation tools like Unitran, it's like Epitran, that will give you pronunciation, at least for a first approximation. It's often okay. We did that for the wilderness data, and although it could be better, it's definitely adequate for many cases. It's also got training things for building models to guess what the pronunciation of unknown words are. It's also got evaluation tools because evaluation is quite hard. And it's got ways to deploy the built voice under the Festival Speech Synthesis system and the Flight, which is a small footprint one, which importantly runs as a synthesizer on Android. So actually you can build a voice, get a single file, and then you can run it on your Android device. And especially when you're doing low resource languages, the end users probably have Android phones rather than iPhones, because iPhones are more expensive. The Flight runs on iOS, but you can't have a generic form because iOS doesn't allow you to have generic new synthesizers, but Android does. So anything that does reading under Android could use your new voice that you just actually created. FastFox has done at least 750 languages. It's not always plug and play. We like it to be, but there's always something a little bit different when you're dealing with a new language, and so you should be aware of that. Where do you find data if you're not going to record it? Well, audiobooks and religious readings, Bibles, Quran are pretty good. They're usually pretty well recorded, single speaker. It's read speech, so this is probably the best type of speech for building text-to-speech. It requires segmentation into an utterance by utterance form. We have tools that allow you to do that. It can be a little hard depending on the quality, but it sort of works. But actually finding audiobooks is harder than what people think. They think, yeah, we'll do that. We'll go and find some Hindi audiobooks. But finding Hindi audiobooks is surprisingly hard, even though there are lots of Hindi speakers, but actually finding online versions of that is surprisingly hard. Broadcast news is the next one, news broadcasts. Sometimes there's subtitles. These are good things. Usually subtitles are not quite as accurate as what the actual text is in an audiobook. Each show, each broadcast news is usually not big enough on its own, so you actually need multiple shows, so you have to make sure that you can get that. Usually the broadcast news is good speakers. Anchors speakers are usually very good speakers. They're sort of selected to be good at speaking, so they're good for synthetic voices. They're standard when they speak. They don't vary in ways that would make things harder. They have a recognized accent, so that's usually a good thing. So broadcast news is another place to do it. Random audio recordings from YouTube, they're often multi-speaker, which makes life harder. They're not well recorded, or at least varied in the recording, even between sessions, which actually makes things harder to be able to build voices. And even if they have subtitles, so think things like movies, there's music in the background, which is not good. And there are technologies that allow you to remove music, but it's making your life harder and harder. Okay, and everything you do, everything you get that makes things harder will make the voice worse, no matter what you do. So sometimes after a while, it's like, no, I'm just going to get a native speaker to sit in the room for a few hours and record for me, because you'll get something better. Speech recognition data sets are not always ideal, because one of the things you want from speech recognition is varied speech from people. That's exactly the thing that you need in order to be able to do speech recognition. While in speech synthesis, we really want one speaker. We want a consistent speaker. So in other words, it isn't always good. Sometimes you can subset the data, the ASR data, to try to find a consistent speaker or group of speakers that are very similar that can be done. And sometimes it works, especially if it's red speech. But, again, it's going to hit the quality if you're going to use a number of different speakers. Cross-lingual models. So how do we synthesize with a nearby language? This sometimes works. It really depends on what the accent is. It really also depends whether people are used to hearing accented speech from that other nearby language. And they may be, because often people are very used to hearing non-native speech. And in other languages, people are not used to hearing non-native speech at all. And so any accent is considered really weird. It could be done naively. You just stuff the text into the other synthesizer. Actually, there are a number of index synthesizers that do this, that just say you can stuff the text of any language into it, any of the Indian subcontinent languages. And it sort of works because phonetically the languages are relatively similar. It's not completely true, but there is a distinction between North and South, but still they're much more similar than, say, what the European languages are. And it sort of works. And because it's very common to hear non-native Hindi speech, it's sort of okay if it's Marathi accented or Telugu accented and people still understand it. But you can do that, and sometimes that works quite well. It really depends on the particular languages that you're dealing with. How can you improve cross-lingual models? So one thing is changing the pronunciation models. So you take into account the phonemes that are actually available in your donor language, and you try to map them appropriately for your target language. And this can make things a lot better. It sounds like a more fluent speaker of the target language. It still may have the other language accent, but it makes it more acceptable. Okay. And so you can get something that's better than just naively putting the text in. Evaluation really sucks in speech synthesis. It's really hard to do. You really need the end user. There are objective measures that maybe look at some sort of spectral distortion, capsule distortion between generated speech and natural speech. And there is a correlation, but it doesn't tell you the whole story. You almost always need some form of human evaluation. There are at least two dimensions. There's sort of a preference thing. Do you like it? And it's something as vague as do you like it? It's not a naturalness thing, because you can get incomprehensible natural sounding synthesis, and you can get fully understandable non-natural synthesis like the Stephen Hawking voice. And there's also understandability. can you understand the words in the synthesizer, which is sort of independent of whether you like it or not. We've been running an annual competition since 2005 called the Blizzard Challenge, where we release a data set to people and ask people to be able to build a synthesizer out of that, and then we test it through listening tests. We primarily nowadays do 2 sets. We ask people for mean opinion scores. Give me a score of how much you like this. Okay, and we find people are consistent across different groups when they're doing this. Is something as vague as like. And we also do this thing about semantically unpredictable sentences. We deliberately create sentences that have no relationship in the language model. So we take some genetic form of, in English, we can do this in other languages, English, determinate, adjective, noun, verb, determinate, adjective. And we put low frequency words in there. So you get sentences like, the sorrowful premiers sang the ostentatious gymnast. And I'm going to play you that example, okay?
The sorrowful premiers sang the ostentatious gymnast.
If you do not see the text and I asked you to write that down, it would almost be nonsense. And that's a natural speaker, that's Rich Stern, and he still hates me for the fact that I made him read these sentences way back in 2005. We now do this in other languages, but it's a really good way. We ask people to listen to it, write down what they hear, and then we calculate a word error rate with the actual form. The word error rates are very big, but we get strong distinctions between different types of synthesizers, and it allows us to be able to evaluate the quality. I should say non-natives find this much harder, even very fluent non-natives. So the Indians out there will find this much harder than what the Americans, even though, you know, you've almost been speaking the language for the same amount of time, but because you learned it a little bit later in life, it's harder. And it's not supposed to be harder. That's not really what we're measuring. We're deliberately making this hard so we have a bigger word error rate, so we get easier ways of looking at distinctions between quality and the synthesizer. But you should be aware that that's actually, that test actually can be used to detect bilinguals and non-native speakers. But it wasn't designed to do this. So summary, there are 3 components, text analysis, pronunciation and prosody, and the waveform generation with good data. It's relatively well defined like ASR and what you do, but you need the right data, and it's quite expensive to be able to get that. Finding data and tidying it up can be hard, but there are tools and techniques that allow us to do that. Evaluation will always inform some form of human listening, especially if you don't understand the language. Building a synthesizer, when you play, you think, yeah, it sounds Chinese. And then you play it to a Chinese person and they go, yeah, is that Vietnamese? So you can't tell. And even if you're relatively fluent in the language, you also can't tell how good it is. And you really need natives to be able to do that. Cross-lingual synthesis can sort of be done with care. And actually today's discussion point is zero-shot TTS. Okay, so this is cross-lingual synthesis. Choose a language to make a TTS engine for, and a second language to use to synthesize it. So, e.g., imagine that you want to synthesize Dutch and you have a German synthesizer. Okay, how much do each of the TTS components affect the target language output? So, text analysis, pronunciation, prosody, and acoustics. How much does that affect the result, and what influence is on there, and what could you do to maybe mitigate some of the issues on that? Okay. And also, I'd like you to think about the social political consequences of what you have when you have some sort of foreign accented result. Or is there going to be problems with that? Are there going to be less problems with that? I'd like you to think about that too. Okay.